Hi, Sir Manny. Nakamute pa po yata kayo.
Hi, can you hear me?
Ayun.
Good.
Yes, sir. Ayan na.
Okay. Good, good.
Yeah.
And how do I put the PowerPoint presentation in? Later, maybe Michelle can help, or I can turn on.
Sure thing. I have it on cue, sir.
Okay. Can I do a share one?
Yes.
Where would I do that? Tap video, share screen.
Yes, sir.
Okay. Click share screen.
Mm-hmm.
This is tap other share screen. Do you want to continue? Yes. And I want to do share of my, where is it? I have to open it.
Mm-hmm. That's true.
Of course. Hang on. Okay. I'm also going to try to share this if I could.
Mm-hmm.
Okay.
Excellent.
That's this JEP software for the second half of the talk. Let me see if I could open the PowerPoint too. Where is it? Here it is. Can you see that?
We're seeing the Jump Pro window right now.
Okay. Can you see the PowerPoint one? No?
I think you need to stop sharing this screen, sir, and then.
Okay, let's see. Your screen is paused. Maybe I go live. Okay. You share? Oh, maybe here.
We're still seeing the Jump window.
Yeah.
Oh, and now we're seeing your desktop.
Yes, now I'm opening. Do you see this one? The PowerPoint?
Oh yeah, now we have the PowerPoint.
Oh, okay. So you have I have the PowerPoint, and I'm later on I'm going to shift to the jump window. Can you see the jump window now?
Mm-hmm.
Yes. Okay. So we'll start with this, and then as we go along, this is going to be very short. Your students will be happy. 30 minutes, maybe.
More
Unless
time
they
for
have questions.
Q&A.
Okay.
Okay, so we're okay. You can hear me. That I'm happy with that.
Excellent.
Okay. Sir, there seems to be a
What's that?
I'll fix baka it's on my side. Oh yeah. Okay. Yeah, because I had the YouTube stream on. So
Okay. What is that?
so we're streaming your talk live on the Triple E Facebook page via YouTube as well.
Uh-huh.
So some of the students will probably join via YouTube, not on the Zoom link. Yeah.
Yeah, I see the EEI information. So that's the one.
Yes,
Yeah.
sir. Yes.
So there's more than just one There may be as many people there as, but I can't see them.
Yeah.
Yeah.
So you now have your 1 hour of fame on YouTube.
Okay. Boy, I'm famous for 1 minute. Whatever. It's okay. It's all right. So how's everything at the UP? Is everything okay?
Yeah, we've started our classes last September, and
Uh-huh.
then but everything is done online, so
Okay.
there's no face-to-face meetings. So it's a bit
Mhm.
different this semester. I'm not sure how it is in the US. I think we saw on the news some states have started person in person classes already.
Some have and some have not. So depends. The high schools and elementary schools have the private schools have open in person. The public schools usually are still online, maybe
Oh,
until
okay.
next month. Yeah.
Okay.
In um, in the universities, most most are online except for certain courses that they have to go in person, but only for I think part of the time. So
Oh,
hopefully
okay.
this will all be finished by in a month or two. When we have the vaccine and what have you. It's how about in UP? I could see that Michelle is having a mask there. I'm at home, so I don't have to wear a mask.
Yes.
Yeah.
Yeah. I'm at
Yeah,
I'm
they're
I'm at
in
the
the
office.
office.
Yes.
Yeah, you're in the office. I understand that.
Yeah.
Um, when is your students graduating? Soon? Last week? This week?
Oh, we changed the semester this year, so there were a lot of changes to not just how we conducted classes, but we had to move the start of the semester. So usually the start of the first semester is in August, so we moved it to September, and then we
Uh-huh.
shortened the semester as well from the normal 16 weeks
Yeah.
to 14 weeks, which I know a lot of other international universities have moved to already. I'm not. I think your university would probably be at 14 weeks
Yeah.
for quite some time now.
Yeah.
So yeah, the first semester is September to December, and then we're not sure yet what will happen during the second semester. I think they're still trying to monitor the situation if they can allow selected in-person classes. Yeah.
Mhm.
Um,
Yeah. But I've been reading the news over there in Manila Times and so forth. You have some, but it's not as bad as some other countries, I
yeah.
think. Yeah.
It could be better.
Yeah, it could be
But
better, of course.
we
Yeah.
are not as bad, but how we were hoping it could be better so we could try to resume some normal
Yeah.
activities. Yeah.
Yeah.
So
That's
so
always the
actually
case.
today we just finished the my own daughter's start of classes. So
Uh-huh.
the classes were moved for elementary and for primary school, elementary and secondary. The dep ed the moved it to October 5. So today is actually their first day of classes as well. So
Wow.
for the entire
Okay.
country, the dep ed has been very cautious. They suspended face-to-face classes for the public schools, even for the low risk areas.
Mhm.
So yeah, I'm not sure how they'll be able to. Hopefully, they'll be able to pull it off for the remote places.
Yeah.
But some private schools have started their classes already since June or July in
Yeah.
some areas. Yeah.
Yeah. Well, over here, the Catholic schools had started already with in person, but the
Oh,
public
okay.
schools still have not. Yeah. So
So,
soon, I think.
isn't it? I'm wondering about that. Is it like when you say uh, in-person classes, like
Yeah.
in the normal,
The classroom,
i-
yes.
i-
Yeah. The classroom,
there's
yes.
just masks and physical distancing, but everything
Yeah.
else is.
They just have a few in the classroom,
Oh,
and there
okay.
maybe five or 6 feet distance in each other from each other. So they seem to be doing okay so far, mostly. And if they have any case of a COVID, they're immediately taken out and quarantined, and then they try to trace who they have talked to, because they're not allowed to talk to with for they're only allowed to talk to each other for less than 5 minutes or something like that.
Wow.
They cannot they cannot socialize with each other.
That must be hard. I can't imagine, school age,
Yeah,
kinder,
I know
grade
it's hard.
one kids.
It's hard for them.
That must be a
Supposedly
challenge.
because you supposedly because you can pass it on if you talk to a person for 15 minutes, something like that.
Okay.
So we will see. And so how do we know when we start there? When at exactly 10
Um,
o'clock?
we'll probably start in a few minutes,
Yeah.
probably in 5 minutes. Let me check. We do have a number of participants via Zoom, but I'm not sure with the YouTube stream.
Hmm. Right now, we have 8 people on board via YouTube and um,
You can tell how many are on
yeah.
YouTube? Oh, yeah. Because I always tune in on YouTube to listen to everything, history and music and okay, doesn't matter. This is I like to do this. I like to talk to undergraduate students, sometimes even high school students.
So yeah, thank you very much for. So I know it's still the weekend at your end. It's a Sunday night
Yeah,
there, so
Sunday night.
we're asking you to work on a Sunday night. So sorry for that.
It's not work. It's not. It's fun.
Okay.
It's good to see all those smiling faces over there, yours and Michelle.
Yeah.
Yes.
It would be great to catch up with you another time as well.
Yeah.
But yeah, I think we can probably start already, so you don't have to
Okay.
stay up so late.
Well,
And
one more minute. Not, my clock is showing 9:59 p.m. So we'll
yeah.
see. Okay, soon. Okay, we don't want to start too early, and sometimes maybe now it's better, but there's a difference between Filipino time.
We've been trying to change the Filipino time.
Yeah, it's okay, but I understand it.
Yeah.
Okay, now it's 10 o'clock.
Okay.
Would like me to, you
So
want to say anything? Then I'll
um
start.
yes, sir. I'll just introduce you for a bit.
Sure.
Um, so thank you very much, everyone, for attending this talk. So we are very fortunate to have an expert zooming from the US. It's a Sunday night at his end, and we are so happy he was able to accommodate us even on a weekend night. So just a moment. So Dr. Manny is a professor of chemistry and statistics at the Applied Physics Laboratory of the Johns Hopkins University in Maryland, USA. He finished his Bachelor of Science in Chemistry and Chemical Engineering from the De La Salle University and University of St. La Salle. And he took his PhD also in chemistry at Case Western Reserve University. He was a Fulbright Scholar at Yale and Case Western Reserve University, and he also undertook the postdoctoral fellowship at Rice University and the Free University of Brussels. His current expertise is in materials characterization, modern chemical analysis, failure analysis, statistical methods for quality assurance, testing, reliability, and modeling and development of chemical sensors for health and safety monitoring. He has extensive industry experience managing many tasks at Johns Hopkins University and the General Electric as in various roles as a lead scientist, as project manager, as line supervisor, conducting investigations of systems failures, mostly involving materials and processes. He has served as an expert witness for failures of high-density polyethylene pipes and for a patent infringement case involving an inorganic material synthetic process, and was also a consultant for several manufacturing companies on various process optimization and quality assurance tasks. Actually, what is most interesting about Dr. Uy is that with the nature of his work, he has uh, been part of a lot of Department of Defense projects, including the ballistic missile defense, Delta programs, the NASA's GeoSat, AMP-TE, HUT, and Messenger programs. I remember when he gave a talk while he was here in the Philippines at Triple E, the example he gave was out of this world because literally it was about a mission to Mars. So that really excited the students. I'm sure that was one of the talks that you will surely remember if you were able to attend that. So he's also an expert in design of experiments, and that was how I was able to meet him. He was the one who came to introduce to us the design of experiments course in I think 2016, and which we've been running for quite some time now. We use it for computer simulation and for field testing, retrospective data mining, reliability prediction, system performance optimization, and a whole lot of important aspects of research and design and process optimization. Aside from that, he's been a member of numerous Tiger teams to assess causes of failures and recommend corrective actions for many Department of Defense, NASA, and commercial programs. He is currently teaching statistical courses, including design of experiments at Johns Hopkins University APL. Aside from his extensive industry work, he is also a researcher. He has co-authored almost 200 papers and also have 10 US patents issued and was recognized in 2001 by the university as Inventor of the Year. So thank you very much again, Dr. Uy. Today he is going to talk about what is the difference between a bachelor's degree and a graduate degree, a master's or PhD, and how research will be able to get you there.
Thank you, Joanna. Thank you for that kind introduction. Uh, when Professor Pedraza asked me to see whether I can give a talk on the difference between a bachelor's degree and a graduate degree, usually a PhD. This has been a favorite topic of mine when I talk to newly graduating seniors, because up to now, you have learned as a graduating senior that your knowledge that you have gotten from your professors mostly now comes from textbooks. Okay, these textbooks have been written by people who had done the discoveries, and people from way back, from Aristotle all the way to Einstein, had discovered a lot of scientific rules and laws, and they wrote textbooks on that. And this is what you learn in a bachelor's degree. So the difference is really, in a word, books, textbooks. If what you learn comes from textbooks, that means that you would have a bachelor's degree at least. And maybe sometimes if it's a little more advanced, you might get a master's degree. However, it has been recognized by universities around the world since the beginning of the Middle Ages that to get an advanced degree, especially a PhD, you need to learn or to discover a portion of, I can't see you need to learn or discover a portion of knowledge that has not been discovered before, that is not from books. So after having this contributed an original idea into the pool of human knowledge, okay, then you would have earned the title of Doctor of Philosophy. That is the biggest difference between a bachelor's degree and a doctoral PhD degree, in that you have contributed some original idea of research into the pool of human knowledge. And I could almost show that to you in, well, first the historical perspective, coming from the Middle Ages. A PhD is, of course, as you know, a Latin for Philosophiae Doctori, which means Doctor of Philosophy. And it does not indicate what subject. It could be engineering, electrical engineering, chemistry, statistics. But you are now a Doctor of Philosophy of some part of human knowledge, okay? Be that some other things. These Doctor of Philosophy degree had been conferred on scholars for advanced scholarship, all the way from the Greek times, that is about one to maybe 2000 BC. And that, while the Greek, there are two kinds. The Greek started mentioning the PhD, Doctor of Philosophy, if you are a scholar because you love knowledge. Remember, at that time, the Doctor of Philosophy, that they thought you know everything. There's no specialized knowledge. There's no medicine, no math or anything. You just know everything. Okay. Towards the Middle Ages, they become specialized into physics mostly, and chemistry and so forth. But now in the 20th century, and the 21st century now, its present definition is that is the highest degree awarded for exceptional knowledge contribution to the existing body of literature. That means a PhD has to be able to have contributed some original knowledge to the pool of human endeavor. Okay, that has not been published before. That means your thesis, for instance, had never been done before. It's original, and therefore you are awarded the Doctor of Philosophy degree. So in a nutshell, the degree of PhD is awarded by universities in the Philippines, in Japan, Australia, United States, Europe, after you have done a rigorous study in a particular field in which the awardees have developed the skills for contributing original ideas. The original ideas. That is, you have done a research paper, for instance, which in turn will enable them, the new PhD, to be able to guide students now to obtain their own PhDs, as Dr. Pedraza is doing now with some of your PhD students. So far, so good? Okay, so what do we mean by having contributed to the font or to the pool of human knowledge? My favorite example for this is the exact words of Sir Isaac Newton. I'm sure you all know who Sir Isaac Newton was. He was the founder of Principia Mathematica, which sets out the three fundamental laws of motion. Okay, and he was also the co-inventor of calculus. Okay, but when he was asked Or when Sir Robert Hooke, for instance, asked him, how come you're so smart? Okay, this is what he said. He said, if I have seen further, it is by standing upon the shoulders of giants. So in other words, he said, yeah, I may have done all of these things, but it would not have been possible if the people before me had not done their work. Okay, so there are many other scientists who had built his foundation, and he was able to do that. So I try to look at this thing. This is just my own way of thinking. Here's the pool of human knowledge, a big human. Okay, and you are here right now, where you have a bachelor's degree, and you have actually learned a lot of things from people who had contributed before you. Okay, and that's why you have a bachelor's degree. If you keep on going further and further, and I don't think the level of difference is relative. Okay, you might have gotten a master's degree, which has a little bit of original work, and then you might get a PhD, in which you contributed an original thesis, a PhD level thesis. But then there is a huge difference between all the PhDs in the world and what I call the Nobel laureate. Okay, only very few are awarded this in the world. In physics or chemistry, one or two maybe, and you have to be alive to be awarded this. So it all these levels of competence is really saying, what have you done to increase the pool of human knowledge about science or humanities or literature or what have you? What have you done to increase our understanding of the world, for instance? Okay. So that is to me, the difference between a PhD and a bachelor's degree is, what have you contributed towards the pool of human knowledge? It's hard for me to think about this, but so I have here an example of a recent graduate student from Cornell who was doing his PhD thesis, and he thought of how can we contribute to less warming of the environment? How can we reduce carbon dioxide when we burn fossil fuels? And his answer was, maybe we could use carbon dioxide as a raw material to make, say, bottles or plastics, so that it's not in the air anymore. So he did his thesis, and as entitled it, a waste gas polymerization experiment. And I'll tell you later who the graduate student at Cornell is. But he worked on this project for several years using catalysts, and he wanted to convert CO2 into plastics, which are important for us, and not just from petroleums. And during the course of his research, he was able to suspect or point that these 10 different factors or parameters for trying to trap carbon dioxide into and make it into plastics are the most important ones. There are 10 different ingredients, in other words, or factors. Some of them you would know, like the temperature and the pressure and agitation, and some sort of additives that he just called that A, B, and C, and a catalyst. Okay, so he was able to figure out that in order to trap carbon dioxide and make them into plastics, he has to use these 10 different parameters and go and find out what are the combinations of these parameters so that he would have the most effectiveness in trapping carbon dioxide. Well, the problem is that if you do all combinations of 10 factors at even just 3 levels, you know, the low, medium, and the high level, you need 59,000 experiments. And 59,000 experiments at the rate of, say, 1 day, 1 experiment per day, he would need about 100 years to finish. So there's no way that he could do this and even live through it. There's no way he can finish this thesis in 100 years. So what does he do? You know, he went back to what Sir Isaac Newton said, you know, well, look to see what are the giants before me? What have they done to solve this problem? And he found it in what he called design of experiments, which is called the shoulder of giants here. This is the paper that he saw. It's published in 2011. It is a class of 3-level designs for definitive screening in the presence of second-order effects by Bradley Jones and Christopher Nachtsheim. Now, Jones and Nachtsheim are therefore his giants, okay? He used this paper to produce a 21 experimental design, and I can show you how he has done this using JUMP. But to give you an indication, this thesis was so well received that the Aramco, the Saudi Arabian oil company, bought the rights to this invention for $100 million. So it was a very lucrative thing for him and for the university. Okay, so what I want to do is go into JUMP, and you can follow in some of these things here and see how that goes. Okay, let's see if I have the JUMP here. The first thing to do is design your experiment. And what I do is open up all these 10 factors. There are 10 here. Okay, there are 10 there. And then I know that it's a little hard for you to, but believe me, it's easy once you have learned this and taken the course in design of experiments, which Dr. Pedraza teaches there. So I would go to this definitive screening, just like the paper said, and I would say, okay, now load this 10 factors, and there it is. I would just to pull this down so you know that there are 10 there. There are the 10 factors there, and the values are from low to high. And I will, what am I trying to find out? I'm going to find out yield. Yield. And I want to maximize that yield. Okay, so using a definitive screening design from that paper and putting all these 10 factors in here and the yield as the response, I press continue. This is very quick, you know, and then I would just say, I put 0 in there and make a design, and immediately came up with 21 runs design over here. These designs are what we call orthogonal designs, so that there are no, this is a higher level math, but there are no off-diagonal axes. So we're looking for eigenvalues, okay? So we click make the table, and suddenly it says, you run this experiment and you should be able to get your results, okay? 21 runs. You run this you do not have to do 59,000 experiments. All you need to do is 21. And you would be able to get your answer. So that's what he did. The graduate student did. And I will show you his result. Except that instead of 21 runs, he added a few more. He added 3 more. Let's see. I can open his data. This is coming from his work. This is his data there, his thesis. Okay. He ran all 20. He ran 24 runs. The last 4 was what we call confirmation runs, but it's not in the beginning. He did not have these 4 runs, and these are his results of 24 runs using the design of experiments. So the first run, with the first run here, his yield time t is 1.3%. Okay, and he kept going over to that, and using carbon dioxide coming off the smokestack. How do you then analyze this? Well, you use statistics, and I don't want to bore you with it, but what it is this model, which in which we try to do a regression of yield versus the factors and all the 2-factor interactions and all the quadratic terms. Okay, and I'm sure Dr. Pedraza would be able to explain this to you in a much longer course, but the result is this. Okay, the stepwise regression. We say, yeah, go ahead and go 1 step at a time until you finish all the terms that are important to you, and then you run the model. And this is the model that it comes out that are important, but then you can probably make it better by getting rid of some of these non-statistically significant terms, like this, until all of them are significant. And this one is just, no, you cannot take that out because that is the main effect. So we'll go this one and see if it will let me take that, like this, and we probably say no, yes, will not let me take that out. But this is all easy to do. This is called model simplification. And there it is. That I cannot do it any simpler than that, because all the terms from here, squared of the temperature monomer times temperature of the catalyst, and so forth, are all significant above this blue line. These 2 are below, but I could not get rid of that because a higher order term contains those terms also. So we're all ready. That's the simplest model I could do. And from there, I could do what they call a profiling. Okay. And from the profiling, I said, give me the best combination within these factors that will give me the highest yield. And I would say, okay, go to optimization and maximize my desirability. And there it is. It says, you know, if I put my monomer to the low level, the additive A at the medium level, additive C at the low level, the temperature at about 200 or something, 0.275, and the pressure at the high end, I should be able to get 15% yield. 15%, that means the yield, all the CO2 that I put in, I get a 15% yield, which is not bad, okay? So what happens there? Um, he, he used all of that. He used, he used all of that term. And this last four here, he he did not do that before, but then he said, okay, let's see if it works. So he put all of that terms here, and indeed he got 15. It's a little higher than 15, and 16. And then he also tried to see what is the low end, and he got 2%. Okay, so he was able to what called validate his model, his predictive model. And this is something that I have to tell a lot of my students, that you can come up with any model, but it's still a model unless you validate it. And that is, you go back there and try it and prove that it works. And in this case, his works. Okay. So because of that, he was able to sell this process to Aramco. He became very rich. His name is, they founded a company called Novomer. His professor is Jeffrey Coates, and this graduate student is Scott Allen. Okay, and I think Scott Allen is now running that company, a very successful company. But he got his PhD too. The money is like an extra bonus, but he got his PhD too because he was able to contribute towards human knowledge that you can indeed use carbon dioxide as part of a process to make useful products. Okay, so to the graduating class, here is I only plan to talk about 30 minutes or so with question and answer for this. What I wanted to say is good luck in your next journey. You think you might be finished, but you're not. Either you go to work or you go on to graduate studies, and you will never be really just like I am. You'll never be able to see in your life that you're finished. You should always keep on going and keep on learning. You must apply all your talent, God-given talent, to any work that you decide to tackle, either in industry or grad school. And never do anything half-heartedly. Always try to do the best you can with everything that you've got. So, graduates, good luck and God bless you and your family for your next endeavor. I'm all finished, and I hope I was able to give you something to think about, and maybe it will help you in your next endeavor. Thank you very much. I'm open myself to questions now if you have any.
Okay. Thank you very much for the talk, Dr. Manny. If you have any questions, you may post them in the Zoom chat, or Michelle, if there are any questions in the Facebook stream.
No, not getting anything. So that may be another problem that we have. I know that the graduates of UP are probably one of the best in the country, right? But whenever I get Filipinos in my class here in the United States, I have to sort of prep them and say, I know that in the Philippines you don't raise your hands or are shy and so forth, but in the United States, and as well as in other places, Europe or Australia, if you want to know something, and you don't know it, if you are curious about something, go ahead and ask. Okay, what can you lose? But so that's another lesson that I guess I could impart on you guys. If don't be shy. Be brave, okay? Because the future is yours. You know, we're old guys. We're going to go off in the sunset soon, but you guys are still starting. Try to do the best you can. Okay.
Still
So
no questions over Zoom and YouTube. So I guess this is for the students who are here joining us over the Zoom meeting. So if you have any questions, you can also chat them over the chat pane. If you're shy, you can message us privately and we can read your questions to the panel.
Okay. Siguro just to warm it up, Sir Manny, I'll shoot two questions
uh,
because this is the common, not really problem, challenge I have with the students. First, what is the difference really between a master's and a PhD? Because here, unlike in other countries, we think it's a ladderized path.
yes,
You get from bachelor's, you need to get a master's first, and then if you do well, then you get a PhD. But that's not that's not the case. I mean, you the preferred path by other countries is from bachelor's. If you have what it takes, then you go directly to a PhD. It's not
yeah,
necessary for a master. So for them, that's a it's the big question. What really is the difference between a master's and a PhD? And
yeah.
then the second
There,
question, sorry,
yes,
the second question is how do you know if you're ready from bachelor's to a PhD? You don't need you can you don't have to go through the masters anymore.
yes, yes. Now there are different philosophies about master's degrees here in the United States. Um, the real prestigious universities like Harvard and Hopkins and so forth um, prefer to give a master's degree with a thesis. Okay, that means it's not as long or as involved as a PhD thesis, but they prefer you to have to write a thesis, which means you do some research and then a little bit of research, and then they might give you a master's degree. There are some other universities and colleges though, in which they call them the new thesis master's degree, and that you just pass a certain number of courses that are the 200 and 300 level courses, and then you get a master's degree. Okay, but most prestigious universities here uh, does not do that. Okay, um, and some others do. So I would say that in a lot of cases, master's degrees are given to a lot of PhD students who somehow could not does not have enough time. Maybe they're something happens in the family, they had a baby or something like that, and they just said, "I want to quit right now. Maybe I'll continue later on, but I want to take a break. Would you just give me a master's degree?" And they might do that depending on your situation. So a master's degree for us here in the United States is kind of could be a thesis degree or a non-thesis degree. Okay, but certainly a PhD is always a thesis degree, and most universities, including mine, require that you stay on campus to do your research for at least a year. Otherwise, they will not give you a PhD. There are universities, though, that sometimes they do not require that, but at least in my university, we want to make sure that you know how to apply yourself into an unknown problem and solve that problem. That's what a PhD to us means here. I don't know how it is in the Philippines. So uh, I've heard sometimes that They don't require a thesis either for, I don't know, even a PhD. That may be because of lack of resources. I'm not sure. But the real meaning of a PhD is a thesis degree. And a thesis means you have work to increase knowledge. That's what it means. Okay, doesn't have to be very big, but it's new. It's new knowledge. Okay, do you think that's fair characterization, Joanna, Dr. Purasta? You got your PhD from Australia, didn't you?
Yes, sir.
Yeah. So,
So
you have a thesis there.
yeah.
Yeah.
So it's so for your question, for the triple E master's program, there are two. We have the Master of Science, which is the thesis option, and then we have the
Mhm.
Master of Engineering, which is the non-thesis option. So you we give a comprehensive exam instead.
I
But
see.
even the thesis option has quite a number of coursework units.
Yes.
So yeah, so it's unlike what in other universities like where I took my PhD. If you have a master's by coursework, it was all coursework, and if you have a master's by research, you didn't have any coursework. You only did the thesis the whole time. So
Yeah.
it's kind of a mix between coursework plus thesis. Yeah.
Yeah. Yeah.
So
So it depends on the university on what, and I guess it also depends on the topic. If it's engineering or management or science, So yeah, a master's degree could be any of these. It's in between a bachelor's and a PhD. So that's about the only thing that I can think of a master's degree. That you have something that's you did more work than a bachelor's degree,
mhm.
but not enough to get a PhD. Well, that's about. I guess that's a fair enough characterization of what a master's degree is.
So we have a question. I'll just read it out. Is it true that it takes longer to get a PhD or a master's degree in the US compared in the Philippines? Um,
Compared to,
to the Philippines. How
uh,
long does it take for the master's program and a typical master's program and the PhD program in the US?
yeah, um, the coursework for a master's or a PhD varies from depending on what you already have while you earn your bachelor's. But in general, it's at least 2 years to get a master's degree after a bachelor's degree. If if your thesis may take longer, it may be 3 years. So I'd say between 2 to 3 years for a master's degree. Um, for a PhD from bachelor's and not going into a master's, uh, it might take you from 4 to 6 years to finish your thesis. Okay. Now, if you want to go teach, though, you might need to go and work as a postdoctoral fellow. This is like in the medical profession, it would be like being a resident in a hospital. That you might want to go work under a famous professor and write some papers with him, so that you could use that in your what you call that, your resume, to get a good appointment in a good university. So yes, about 2 to 3 years for a master's, and maybe 4 to 6 years for a PhD. And now some people prefer to go have a master's first and then go to PhD, and that it might also still take them the total of maybe 4 to 6 years. It depends on how you are good at the. Some people can finish all their course requirements in a year. Okay, some people don't. You can finish it in 2 years, and then you do your thesis, and the thesis is really the one that determines whether you are given a master's or a PhD. If you're going to go for a thesis master's, the how hard that thesis is, and and if it's very hard problem, you get a PhD. If it's a very not so hard problem, they might just give you a master's degree. So it varies from university to university, department to department. Um, for instance, I guess for when you get your master's degree, master's in business administration, an MBA, I don't think most universities require a thesis. You just do your courseworks. So it all depends, you know. Um, but it's always been. I know that I am biased because I got a PhD, but there has been some sometimes. Okay, there's been some discussion sometimes. The medical degree in the United States, an MD degree, because a medical degree, you get an MD degree without doing any research most of the time. They're all from books and from practice, practice. Like you go to the hospital and you learn how to do certain procedures and so forth. And they're saying, is that really a PhD or a doctorate or just a higher level bachelor's degree? So sometimes those are fighting words for, medical doctors. But that's the classical way of being called a doctor means that you have contributed into the pool of human knowledge. That's a classical definition of a doctorate of anything. But then again, if you study into law, you get a JD, which is Doctor of Law. Really contribute to human knowledge. And maybe it's very clear for sciences and engineering, electrical engineering, and so forth, that to get a PhD and the thesis and so degree in I believe in have a bachelor's degree. One is a lower level, and then they have the license, which is equivalent to a master's degree. But it's mainly because in Europe their 4-year undergraduate degree is very, very intense, and it includes a lot of master's degree level courses. So most people in the United States, if they have a license from Europe, they assume that's a master's degree, coursework only. So I don't know how, I couldn't answer it too much more. How do I close that? Okay.
Thank you, sir. We do have a number of questions as well.
Okay.
So
That's
is it
right.
better to do graduate studies right after my bachelor's, or should I have work experience first before doing graduate studies? And secondly, any tips in applying for graduate studies abroad?
Mhm. Is it better to work first before getting a bachelor's degree? Here in the United States, I counsel my students, because it's very expensive here to go to graduate school. And what I would counsel, I know a lot of my professor friends does not agree with me. I'd say if you can work for a company after a bachelor's degree, and if they have a graduate program where they would give you time and pay the tuition for you to go into graduate school, you do that because you get a graduate degree. Say you just get a master's degree after 2 or 3 years. You graduate. When you graduate, you already have 3 years of industrial experience. Okay. Uh, that's the best, at least for my way of thinking, that's the best course of action for your students if they can get that. However, I don't know whether they have those kind of things in the Philippines. Okay. Um, so the second thing is if you go directly to graduate program, um, it is it's a lot of hard work, and then you might not have a job when you're finished. So you have to think about all of these things. Um, this is the problem we have in the Philippines sometimes. It's that you get a graduate degree, a PhD, and you might not have a job. So it's a tough thing, and I wish we could solve that problem in our country, but that's just the definition. I think our industries are still not mature enough to fund, to hire PhDs and fund research, good research. So it's a tough problem for our people there. So you might have to go to the United States or to Europe or Australia, and then see if you can, once you get a master's or PhD, see if you can get a job in the Philippines. If you can't, then it's not your country's fault if you stay in Europe or Australia or the United States, like I did. When I got my PhD and postdocs, I wrote 100 letters to all sorts of places in the Philippines, and I didn't get any. This was way back in the 60s. Didn't get any job. So I said, okay, well, there's nothing I can do. I get to live, and I got a job in the United States, and I've been here ever since. So that's just how the reality of the situation is. I think, what do you think, Dr. Pedrosa? Is it changing now in the Philippines that we could support PhDs, our own PhDs, besides the universities, of course, but in industry?
It's still a bit limited. I'll be honest with that. If you have a PhD, the most of the positions that you're going to have will probably be in a university, in an academic setting. Aside from UP, the other universities like LaSalle, like their alumni have been very aggressive in hiring PhD graduates, and there's a push for them to improve the graduate program. But yeah, it's most of the work would probably be in the academe, and also in government. We have the Balik Scientist program in the DOST, so the Department of Science and Technology. But for private companies or industry, there are a select industries where they will welcome a PhD and where they actually have a research and development arm. But it's slowly. It's much. It's not as. It's not the same as in the U.S. or in other developed countries, but definitely there's some improvement.
Yeah, I think there's improvement, all right, and I'm hoping that this will keep on going. So for instance, the recent big push in the world for a vaccine for COVID, think how many PhDs are working to do that. Okay, think, and in my own, my present interest with design statistics and design of experiments, think what kind of necessary background do you need so that you can plan a vaccinating test. You know, you've been reading about Johnson and Johnson or all these companies saying they're starting a phase 3 test with 30,000 human subjects. You know, why is that? You know, you have to understand why 30,000, why not 10,000 or 1,000? And that is because of certain statistical truths. You know, you have to be sure that it works. And how are you sure that it works? You have to be certain to 99% that it works. And some of those things then gives you the idea that you need this many tests. Okay. There's a lot of, some of my friends are busy working on this topic and they're all PhDs. Okay. So I don't think our country, the Philippines, are yet to that point where we can do that. Make vaccines right away and test them. But it's also very expensive. And that's a problem, another problem. Oh, did I just lose something? Oh, okay, I see. What is the other question now, Dr. Pedrosa?
I'll read some other questions. Okay. Should we already have a thesis in mind? Should you have a topic in mind before deciding to go into a PhD?
You should have some idea of what you are interested in, and then look for a professor. Look for a professor that can help you on that. Okay. Say you want to be able to, I don't know whether this is your idea, but say you like gaming, okay, and you want to come up with a new game that you could market, then you might want to work for somebody in your department doing that, okay, or modeling and simulation. Or say you want to see whether you can design a chip, you know, and you have to look for that. So yeah, be very judicious in your choice of professor when you do that, a department. Because if you made the wrong choice, you might waste some time. That's all. You know? And you're not going to be happy. So yeah, it's a gamble of your life, but you have to do it anyway, because if you don't, you'll probably regret it and worry about whether you have done the right choice. Okay. Did I answer that question? I hope I do.
Yes.
I hope I do.
Yeah. So the straight answer is yes. It would actually help if you have a topic in mind already, and Sir
Yes.
Manny just pointed out how important it is to find a good match with
Yes.
your advisor.
Yes, that's correct. Very
So,
important. Not very important. More important than anything else.
yeah, actually, from my own experience, the advisor is as important, or sometimes even more important than the topic.
That's right. That's right. You know. So
So,
especially you get to find a professor who's very human oriented person, you know, who would talk to you and be your mentor. And it's not very aloof that if you have a problem, they will not say, oh, you can find that out yourself. You want somebody who is willing to listen to you. So you should maybe interview your professor, your prospective professors. And, okay.
yeah. Yeah, I think for the undergraduate students, because we did the talk last time on the I did the talk on doing the review of related work where I discuss a bit about the student supervisor roles. I think for me that's the biggest difference. When you're handling undergraduate projects, you're going to examine the project as well. So the relationship is different. But when you have the masters, especially the PhD student, it's more professional. It's more personal. It's not just professional.
Yes.
You're with them for the entire 6 years, so
Yeah.
it's a more personal relationship,
Yes.
unlike with any of the I don't think you will have that kind of relationship with any of your undergraduate
Yeah.
teachers.
In the bachelor's degree level, there's not of that.
Yeah.
But now you're going to really be working side by side with this professor. You better have a good working relationship with that professor. Yeah.
Yeah. So it's it's very difficult sticking to a topic when your advisor and you're at odds. Let's just put it that way.
That's right. No, that's very important. Very important. Another thing that I would suggest when you do research is, and I have told this to, I taught a course there at UP, is learn design of experiments if you can, because that will save you so much time in your research. You know, the example that I gave you, if he did not use that technique called definitive screening design, he would never have succeeded because think about doing possible 60,000 experiments instead of what he did was 24. A big difference
Yes.
in being able to finish successfully. So you don't just go in there and try out anything and by random. Try to think about your problem and design what you're going to do before you do it. Okay.
Yes. So thank you for that. There's another question. It's a bit different from what
Mm,
we've been talking about, but it's relevant to the circumstances. Due to the remote learning, what kind of adjustments should we do when it comes to research? We can't go to laboratories and other things that requires interaction.
yeah. Well, that's very interesting because if you go on this remote kind of situation for a long time, and I hope not, but um, you might need to do a lot of computer experiments, modeling and simulation, where you don't have to go to the laboratory and actually physically do things with your hands. So modeling and simulation would be one. Um, artificial intelligence would be another. Okay, so you might want to find a thesis in which you can get your hands on, say, for just easy example, the traffic situation in Metro Manila for the last 5 years, and then you use AI to say how can I solve this problem? Okay, something like that, or get some big amount of data from a company um, and find out whether you could use AI to improve their manufacturing or process or what have you. So all of that can be done remotely. In other words, try to find data that's just already there so you don't have to generate it. And then see if you can make sense out of the data. Okay. And unfortunately, there's no substitute to actually doing the experiment yourself, but this would be a better way if you have to stay remotely for a long time. But, uh, look at the most amazing thing that happened in the world was Amazon, right? The it's a very simple technique that they have. They use the computer and the internet to sell products, okay? And you do not have to go to the store. You know, even now here in the United States, we've been buying our food without going to the supermarket. Okay, so there are ways. Those are all remote shopping and so forth, and it's creating all sorts of hazards, of course, in the economy, because a lot of stores are closing because they cannot compete with with the online shopping. Okay, but this is the new world that we have to live in. Uh, so you might be able to think of something in that area where you don't have to do it the physical thing, but you can think of a way to get it done faster. Okay, so who knows? I'm not smart enough to think. Well, if I am, I would be multimillionaire. Right? I'd be Jeff Bezos or something. But anyway, try your best to and think about how you can make the best out of this situation. Okay, I don't know enough about it to be good. I like to do experiments by hand, and so I'm not good at. Well, I do modeling and simulation, but I still think of that as an experiment with computers, you know. But that's about as close as I get to remote things, is doing modeling and simulation. You do that too, don't you, Dr. Pedraza? You do modeling and simulation?
Yeah.
Yeah.
Most of
there you
the
go.
work we do in our field in computer networks is in modeling and simulation. Because you
Yeah.
have to look at large scale networks, and it's impossible, and you won't do experiments on a large scale live network. So we
Yeah.
have to do computer simulations first.
That's correct. Yeah. So that's one way. But who knows? I don't know how long this pandemic is going to continue. Maybe, I don't know what your guess is as good as mine. So any other questions?
So far there's none.
Okay. Well, we
Michelle?
made 1 hour.
uh,
So well, let me thank all those who have participated and listened to me patiently, on all my maybe not quite so objective, but view of the world. And good luck to you guys. I hope the best for your future. Thank you very much for having me and listening to me.
Thank you
Thanks,
very
Dr.
much, Sir Manny. Just to let you know, we have 36. There's a total of 36 participants in Zoom, and there may be more via YouTube. So we have a good audience, and we'll also both posting the recording for future viewing of those who are not to join us today.
Okay, that's wonderful, and thank you for listening.
Thank you very much.
Bye.
Bye, sir.
Bye.
Take care.
Take care.